This video looks at solving trig equations which have multiple angles. So the first thing we'll do is discuss what having a multiple angle means, and we'll have a look at a graph of a trig function with multiple angles. When we draw the graph of a trig equation with multiple angles, we see that the graph has multiple waves. So for example, sine 2x, or y is equal to sine 2x. If we were to draw that, okay, here we see that there are two waves instead of the usual one wave. So the 2x part of the function means there are two waves instead of the usual one. This changes the period of the wave. Remember, the period is the length of one wave. So normally the length of one wave is 360 degrees. But if we have two waves in 360 degrees, then the period of each wave is 180 degrees in this case. So each wave has a period of 180 degrees. Now there's a formula that you can use to calculate this, and I'll write that on the next slide. So we can calculate So the formula is 360 degrees divided by the number of waves, or 2 pi divided by the number of waves, depending on whether you're working in degrees or radians. Right, when we solve trig equations with multiple waves, again we begin with the usual procedure. However, we try to leave we do leave the 2x part until the end, like we did with the phase shift angles in the last video. So to solve trig equations with multiple angles or multiple waves, we begin with the usual procedure. However, we leave the 2x part to the end. Okay, we'll have a look at some examples. Example 1. Solve the square root of 2 sine 2x minus 1 equal to 0. And that's going to be between 0 and 360 degrees. So we're working in degree mode again here. Right, so root 2 sine 2x minus 1 equal to 0. We'll rearrange and we end up with sine 2x equal to 1 over root 2. Now before we go ahead and carry on and work out our cast diagram and which quadrants we're interested in, I'm going to draw that function sine 2x again, just to show you what happens when we're solving a trig equation with multiple angles. Okay, so there's our two sine waves between 0 and 360. Now we're interested in a value of 1 over root 2, which is approximately 0.7. So let's say that that is around here. Then in our first wave, we will have 2 values, so that's our two quadrants, and that's going to be quadrant 1 and 2 because our y value is positive, so we're looking for sine positive. However, we have a second wave, so we actually have 4 answers here, and that's what happens when we have multiple waves or multiple angles in a trig function. You end up with more than 2 answers. So for every wave, there will be 2 answers. So we can see for sine 2x, there are 2 waves, therefore 4 solutions. And that's 4 solutions to the trig equation. So now on the next slide, we will go ahead and try to solve this. So we were at this stage here where we had sine 2x equal to 1 over root 2. We'll do the cast diagram anyway, although we have decided the quadrants really by looking at the picture of the graph. So we said that the y value is positive, so we're looking for sine positive, which is the first and the second quadrant. And I do tend to write an additional thing here, which is just that there is 2 waves, so therefore 4 solutions. And just to make sure that you're clear why there's 4 solutions, it's this 2 in front of the x that tells us this. If there were a 3x, we would have 6 solutions because there is 2 solutions per wave. If there was a 4x, there would be 8 solutions, and so on. Right, we carry on by taking the inverse. So it's sine to the minus 1 of 1 over root 2, and we end up with 2x equal to 45 when we do the calculator. So that's our first quadrant. So we need to also find our second quadrant, and that's going to be 180 minus 45. So we have 45 and we have 135. Now, that's our first 2 solutions, and that's the solutions to wave 1. However, as we said when we saw that from the picture on the previous slide, that there is another 2 answers. Now, in order to find the next 2 answers, we have to add 2 pi, or 360, depending on whether we're radians or degrees. So in this case, because we're in degrees, it's actually 360 that we would add. I'll write that on the next slide. Once I've finished this example, I'll write that up. So what we take is we take the 45, which was our solution for quadrant 1 for wave 1, and we add 360 degrees. And then we take the 135, which was our solution for quadrant 2 of wave 1, and we add 360 degrees. So we've added 360 degrees, and that's going to give us wave 2. Oh, it's not liking that there. Wave 2. And basically we've added 360, as I said. So what does that give us? That gives us 2x equal to 45. 2x equal to 135. And then we have 405 and 495. Now that's what 2x is equal to, and we want x, so we have to divide by 2. So I'll just write that there. We're going to divide by 2. So we divide each of these values by 2. We get 22.5, 67.5, 202.5, and 247.5. And that is our 4 solutions for sine 2x equal to 1 over root 2. Okay, as I said, on the next slide I'll write out the method for finding the next wave in the sequence. To find the values in the second wave, we add 360 degrees or 2 pi to our first wave answers. If there are more waves, we would add another 360 degrees or 2 pi, and so on. So for 3 waves, you would add 360 to the second wave values. For 4 waves, you would then add another 360 to the third wave values, and so on until you have the number of solutions that you said you would have at the start. So for the last example, we said we would have 4 solutions because there was 2 waves. So once we've added our 360, we had 4 solutions. And that meant that all we had to do for the final step is to divide by 2 in that case, because there was 2 waves. If you have 3 waves, you'd be dividing by 3 at the end, but you would have had 6 solutions. So you'd have added 360 twice. Let's look at an example now with 3 waves to show you the work involved in that one. Example 2. Solve 3 minus 4 cos 3x equal to 5. And that's going to be between 0 and 2 pi. So we're in rad mode this time. So we would need to change our calculator. And you have the option of writing as exact values, or you can write your radians in decimals. And it's up to you which of those you use. I'm going to go with exact values on this one. However, if you aren't keen to use the fractions and simplifying fractions, taking common denominators, you can use the calculator and use the decimal versions, and that would be fine. So first of all, we need to rearrange. So we have negative 4 cos 3x equal to 2 because we've taken away 3 from the 5, and then we're going to divide by minus 4. So we've got cos 3x equal to minus a half, basically, when we simplify that down. So cos in this case is negative. So we're looking for when cos is negative, which is the second and third quadrants. The additional thing we might want to write is that we have 3 waves because we have 3x. So that will be 6 solutions because there is 2 solutions per wave. Right, let's continue on by taking the inverse cos. Oh, I can't get that to work. There we go. So we'll take the inverse cos, but we ignore our negative sign, so it's just going to be an inverse cos of a half. So that's 3x equal to pi over 3, which is 60 degrees. So pi over 3 is our first quadrant answer. It's not one of our final answers though, it's not one of our final quadrants. So first of all, we'll work those quadrants out for wave 1. So we're going to have 3x equal to pi minus pi over 3 and pi plus pi over 3. So that's quadrant 2 and quadrant 3. And that works out as 2 pi over 3 and 4 pi over 3. Now that's only wave 1, and obviously I've started to run out of space, so I'm going to go back onto the next slide and I'll rewrite that last line again first of all. So we had 3x equal to 2 pi over 3 and 4 pi over 3. So that's wave 1. So because we're in radians this time, to find the wave 2 values, we need to add 2 pi. So it's going to be 2 pi over 3 plus 2 pi and 4 pi over 3 plus 2 pi. And that will give us wave 2, which was plus 2 pi. So let's write down those answers. You need to use lots of paper for these examples. So we have the 2 pi over 3, the 4 pi over 3. Now adding 2 pi onto 2 pi over 3 gives us 8 pi over 3. Basically taking a 4 pi over 3 plus 2 pi is 10 pi over 3. And then we need to find our third wave values because we said we would have 6 solutions. So far we've got 4. So we're going to take 8 pi over 3 and add 2 pi and 10 pi over 3 and add 2 pi. Alternatively, we could have added 4 pi to the original two values. So you could have taken these two and added 4 pi if you'd wanted, and that would have given you the next two values, so the third wave. This here is going to be wave 3. I said we've either added on 2 pi to the second wave answers or we've added 4 pi to the first wave answers. So we're nearly there now. So we have 3x equal to 2 pi over 3, 4 pi over 3, 8 pi over 3, 10 pi over 3. 8 pi over 3 plus 2 pi over 3 is 14 pi over 3. And 10 pi over 3 plus 2 pi is 16 pi over 3. So the final thing then is to find x, so we need to divide by 3. And that just makes it 2 pi over 9, 4 pi over 9. It's just the denominator that's going to change here. 4 pi over 9, sorry, 8 pi over 9, 10 pi over 9, 14 pi over 9, and 16 pi over 9. And they will be the final answers. However, if you want to know what they are in decimals, just in case you're doing this yourself but using a calculator, we would have 0.698, 1.396, 2.793, 3.491, 4.887, and 5.585. Now, remembering back to a couple of videos ago, we talked about pi being equal to 3.14. So if you wanted our domain to be between 0 and 2 pi, then 2 pi must be equal to 6.28. So all of our values, if they're to be between 0 and 2 pi, they must be between 0 and 6.28 in terms of the decimal. And if we look here, our highest value or our last value is 5.5, 5.6. So that is less than 6.28. So we can be pretty confident that our values are correct. And I'll just summarise that on the last slide. So remember, all your final values should be between 0 and 6.28, which is approximately 2 pi. So you can use the decimal values to check your answers. So it could be a good idea to take your first value, your first solution, and your last solution, if you've been working in exact values, and convert them to a decimal answer to check that they are within the domain. So between 0 and 6.28 if it's between 0 and 2 pi that you started with in terms of the question, using pi as 3.14 in the calculator.